In 2013, Boeing made a quiet decision inside a boardroom that most people never heard about. No press conference, no dramatic announcement, just a contract, a handshake, and a choice that would lock in the future of long-haul aviation for decades. They picked one engine, one company, and walked away from everyone else. At the time, it looked like smart business. In hindsight, it was the first domino in a chain that would eventually lead to a $4.9 billion charge, a stock in freefall, and a CFO standing at a podium in front of investors, trying to convince them that the worst was finally over. But to understand where Boeing is right now, you have to go back to that decision, because everything that followed the triumphs, the disasters, the delays, traces back to one engine, one relationship, and one bet that Boeing made before most people even knew the 777X existed. The aircraft was called the 777X, Boeing's next-generation widebody, the plane designed to dominate long-haul routes the way the original 777 had for a generation. And to power it, Boeing needed something the world had never built before. They needed the most powerful commercial jet engine in history. The requirement was staggering: over 100,000 pounds of thrust, efficiency targets that would make previous engine generations look primitive. And it had to be ready on Boeing's timeline, not an engineer's ideal schedule. Two companies could realistically build it: General Electric and Rolls-Royce. What happened next wasn't really a competition. It was a coronation.GE that spent years quietly preparing for exactly this moment. While Rolls-Royce was developing its Ultrafan concept, a genuinely revolutionary design, that technology was still in the research phase, promising on paper, unproven at scale, and Boeing didn't have time to wait for promising.GE, meanwhile, had been powering Boeing's 777 family for years. Their engineers knew the airframe. They understood the integration challenges. They had relationships, data, and institutional knowledge that Rolls-Royce simply couldn't replicate overnight. And then there was the material that changed everything: ceramic, matrix, composites. Most people have never heard of the term. In 2013, almost no one outside aerospace had. But this material, capable of withstanding temperatures that would destroy conventional metal alloys at a fraction of the weight, was already being built into GE's new engine design, not theorized, not planned, built. That detail mattered more than almost anything else in the selection process, because it meant GE wasn't just promising a better engine. They were showing Boeing one. The result was the GE9X, an engine so large its front fan, minus 134 inches in diameter, is wider than the entire fuselage of a Boeing 737. Engine that uses only 16 composite fan blades, where its predecessor used 22. Because advances in fluid dynamics and materials, science made each blade so efficient that fewer were needed. An engine designed to burn 10% less fuel than the most efficient engine that came before it. Boeing chose GE exclusively. No alternative engine option. No competitive split. And that choice came with a number attached to it that very few people talked about publicly. Over 400,000 777X aircraft had already been ordered. Each one needs 2 engines. That's more than 800 engines before you even count spare parts, replacements, and decades of maintenance contracts. Engine manufacturers make more money from aftermarket support than from selling the engines themselves. Exclusive supplier status on a program this size wasn't just a contract win, it was a revenue stream that could last 50 years. But this only matters once you understand what Boeing was building toward and what was quietly starting to crack underneath it. For a few years, everything looked like it was going according to plan. GE was developing the GE9X on schedule. Boeing was assembling the 777X. Orders were strong. The aviation world was watching with genuine excitement. Then 2019 happened, and then 2020, and the years that followed rewrote everything. Manufacturing operation, one of the most complex industrial systems on Earth, began to show fractures that had been invisible from the outside. Supply chain failures, quality control breakdowns, a corporate culture that insiders described as prioritizing schedules over standards. The problems weren't new, but they were becoming impossible to hide. In January 2024, A door plug blew out of an Alaska Airlines 737 MAX 9 at 16,000 feet. No one died. But the image of a hole in the side of a commercial aircraft, a Boeing aircraft at altitude, landed in front of every regulator, every airline executive, and every nervous passenger on the planet simultaneously. The FAA responded immediately. They capped 737 MAX production at 38 aircraft per month. Boeing, a company that needs to deliver planes to generate cash, it was suddenly operating with a governor on its engine, and the 777X, the plane GE had built the most powerful engine in history to power, was quietly becoming Boeing's most expensive waiting room. Here is where the story gets uncomfortable. The GE9X was ready. Technically, the engine had done what it was supposed to do. It had accumulated thousands of flight hours in testing. The engineering worked, the materials performed, the fuel efficiency targets were met. The airplane around it was the problem. Boeing took a $4.90 billion charge tied to 777X delays in the third quarter. CEO Kelly Ortberg stated that the delay wasn't caused by technical failures in the aircraft itself, but by slower than expected FAA authorizations for flight testing. New regulatory requirements had extended the certification timeline in ways Boeing hadn't anticipated. Entry into commercial service, originally expected years earlier, was pushed to 2027 at the earliest. Think about what that means for a moment. Airlines had ordered these aircraft. Some had structured entire route networks around their arrival. GE had built an engine that had no commercial airplane to fly in. And Boeing had taken billions in charges on a program that was, by any measure, its most important bet on the future of wide-body aviation. The 777X was absent from Boeing's recovery plan, not delayed within it, absent from it entirely, which is what made what happened next so significant. A Boeing CFO walking into a UBS conference doesn't sound like news. Finance executives give presentations constantly. Markets move on. Most of these events disappear into the noise. This one was different. J. Malavi stood up and said something Boeing had not been able to say in years. He gave specific numbers, real timelines, measurable targets, not aspirations, not crisis communication. Numbers, Boeing. Stock jumped between 7 and 10% within hours of the announcement. The recovery plan rested on two aircraft that were not the 777X and not the 737 MAX 10. It rested on the planes Boeing already knew how to build: the standard 737 MAX and the 787 Dreamliner, the workhorses, the proven programs, the ones where production, however troubled, was at least moving for 2025. Boeing targeted 440 to 450,000 737 MAX deliveries, drawing down a substantial backlog of completed but undelivered aircraft. But the number that really mattered was the 2026 target: minus 53 aircraft per month, up from 42, a 26% increase in production rate. And critically, Malave stated those deliveries would come from the production line itself, not from burning down inventory stockpiles. That distinction matters more than it sounds. Drawing down inventory is a one-time fix. It makes delivery numbers look good without proving the factory actually works. Delivering directly from the line is proof. It means production has caught up to demand. It means the system is functioning. For the 780, the target was an increase from 7 aircraft per month to 8. But meaningful, the 787 carries higher margins than the narrow-body 737, and its long-haul routes are precisely where airlines are seeing the strongest demand recovery. Malavi also addressed something that had been quietly strangling Boeing's ability to execute for years: Spirit AeroSystems, a name that means very little to most people, but inside Boeing's supply chain, it had become synonymous with a specific kind of institutional headache. Spirit manufactured the structural backbone of Boeing's aircraft. For years, quality issues at Spirit created cascading problems that slowed Boeing's own production lines. Parts arrived with defects. Rework ate up time and money. The separation between Boeing and one of its most critical suppliers had created gaps that inspectors kept finding in finished aircraft. Boeing's solution was to eliminate the gap entirely. The company was completing its acquisition of Spirit AeroSystems, bringing fuselage manufacturing in-house back under Boeing's direct control. The decision to acquire a supplier rather than simply fix the relationship with one is an admission. It says the existing structure wasn't working and couldn't be made to work quickly enough. It says the dysfunction ran deep enough that only ownership would resolve it, combined with investments in workforce expansion, supplier support programs, and improved factory processes. This represented something Boeing hadn't offered in years: a coherent operational plan, not a promise to do better, a structured, sequenced set of changes with defined outcomes. The financial projection completed the picture. Malave stated Boeing expects positive free cash flow in the low single-digit billions for 2026. This follows a projected $2 billion negative cash flow for 2025. The reversal, if it materializes, would represent one of the more significant single-year financial turnarounds in recent aerospace history. He also stated confidence in Boeing's longer-term target of $10 billion in annual free cash flow. That number